Hey y'all, welcome back to another round of engineering. And yeah, let's keep going. So we're still on this idea of linear algebra, and we've worked our way through what it means to multiply matrices. And then after that, we went through some ideas about row operations and how to solve a system of equations by performing row operations on the coefficient matrix. Now I'm going to tell you, or we're going to walk through how to get the final solution a little bit faster. Okay? So, what do we need? We have to start talking about what it means to have the inverse of a matrix. Okay, so today we're going to talk about inverse matrices. Matrices. Okay. So, what I'm going to set up for you is first how this inverse can be used, and then second of all, how do we actually find the inverse? Okay. So that's the general idea. Now, first of all, we'll keep in mind that if I'm thinking of this. So where we have our coefficient matrix A, we have our matrix, our variable matrix, if you will, X, and then we have our resultant matrix B. And we'll start off with that. And how I will indicate the inverse matrix will be something like the -1. So hopefully that kind of makes a little sense. If we had a number, say 3, the inverse of 3 would simply be 3 to the -1. Okay. Bear in mind, however, that this is a matrix, not an individual number. And no, unfortunately, it doesn't work like that. You're probably thinking, well, if my coefficient matrix, let's go ahead and use the old one. So if my coefficient matrix is -2, -3, 1, and 4, -2, and 1, and -1, -1, 1. So if my coefficient matrix is this, can I simply write the inverse of that matrix as the inverse of the individual numbers? In other words, can I write this as -1/2, -1/3, 1, 1/4, -1/2, 1, -1, -1, 1? Is that what the inverse of A is equal to? So here's the question I have for you. Can you think of a way of checking this? Yay, nay? What does it mean to be an inverse? If I do this, if I take 3 and multiply by the inverse of 3, what should my final answer be? Yeah, 1, right? That's the function of an inverse. When you take a value and multiply by its inverse, you should end up with 1, the unity value. Okay? Now, of course, matrices are not numbers, so let's get rid of this analogy, but the same idea holds. If I take a matrix A and I multiply by its inverse, I should end up with, I'll put in air quotes, 1. Except we don't call it 1 for matrices, we call it the identity matrix. In other words, you should have 1 along the diagonal. So go ahead and check. If I multiply the matrix A by the inverse matrix, if this is the inverse matrix and this is the original, and I do the matrix multiplication, do I end up with the identity matrix? Pause the video, hack through it real fast. No. Yeah, you can hopefully you see that, right? You hacked through it. No, you don't. In fact, you don't even have to hack through the whole thing. You just have to show that one of the elements is non-zero, one of the diagonal elements. So let's go through and just show that one of them is non-zero. I will take the first row of A and multiply by the second column of the inverse matrix, the proposed inverse matrix. So this should give me the first row, second column of the resultant. And if it's the identity matrix, that value should be equal to 0. So let's go ahead and check. We can just simply, we'll simply apply our rules of matrix multiplication. So we have -2 times -1/3 plus -3 times -1/2 plus 1 times -1. So you see I'm going across the row and I'm multiplying going down the column. And the question is this going to be equal to 0? Well, let's double check. We have 2/3 plus 3/2 minus 1 is equal to 0. And the answer is no, absolutely not. This does not work. So because we have an off diagonal element that is non-zero, this matrix that we've proposed is not correct. That is not the inverse matrix. So that's the first thing. You cannot just simply take the individual elements of the original matrix and invert them. That does not work. We have to come up with something different. So that's the first piece. The second piece is, why do I care about finding the inverse at all? Which is also good. Why have I spent time talking about this? Let me show you. Again, if I have my coefficient matrix A, my variable matrix X, and my resultant matrix B. Okay. Let's presume that the inverse exists. If the inverse exists, then I'm going to go ahead and multiply both sides of my equation by the inverse matrix. Okay, so if the inverse exists, I can multiply both sides by the inverse. Of course, what is the value of the inverse matrix times the original matrix? And I'm underlining it right here for you. That is the identity matrix. That's 1, if you will, 1 in matrix form. So this gives me the identity matrix over here times my variable matrix and inverse times B. Well, let's go ahead. Let's look at this, the left side of the equation for a second, and I'll use the example from our last lecture. So the example, the identity matrix is a 3 by 3 with 1s on the diagonal and 0s everywhere else. So I'll go ahead and write that down. And I'll go ahead and write down my variable matrix that we used in the last couple of examples. In other words, I had x1 as the first one, x2, and then I called this one y. And then I'll just leave this as is for right now. Now, if we notice on the left side, I am taking the identity matrix and multiplying by my variable matrix. Okay. So go ahead, do that multiplication for a second. What's the resultant? Hopefully you see it, right? If I do this matrix multiplication, I multiply across a row and down a column. When I do this entire multiplication, I just end up with my variable matrix again. It's almost like I took my matrix and multiplied by 1. Now let's stop and look at this for a second. If I know what my inverse matrix is, then I can take my inverse matrix, multiply by my matrix B, and get my final answer. I'll say that again. If I have the inverse matrix, I multiply my inverse matrix times B, and that will give me my final answer. Right? This is doing all of that sub and solve stuff that we talked about last video. So this is a faster way of doing that. Solving it, just find the inverse. Okay. So that's the motivation. And in fact, I believe that this is how most of computer simulation programs do it. They find the inverse matrix and simply do this matrix multiplication. Okay, so let's go ahead and start getting an idea about how to find the inverse matrix. If we can find the inverse matrix, then we can find the final solution. And again, I've mentioned this before, I'll say it again. For physics, for this class, we do not need to prove that the inverse matrix exists. It will always exist. Okay, so what are we going to do? Let's assume that we know our coefficient matrix A. We do not know the inverse matrix. And we know that by definition, when I take my matrix A and multiply by the inverse, I should end up with the identity matrix. Now, I'm going to do two things. First of all, let's go ahead and use the coefficient matrix from the last lecture. And the second thing is I'm going to write it in that lazy mathematician's notation where we don't worry about writing the variable matrix, the unknown matrix, if you will. Okay. So what am I going to write? Well, the coefficient matrix from last time was this. 4, -2, 1, -1, -1, 1. And the identity matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1. Good so far? Now, if I think about the equation, if I'm looking at the top line here, the equation, really what I want to do is I want to take this and I want to get the inverse matrix by itself. So in some sense, what I really want to do is divide, put that in air quotes again, I want to divide the inverse matrix by the, not the inverse, I want to divide the identity matrix by the coefficient matrix. That's kind of sort of conceptually what I want to do. How this is done, because you can't divide a matrix by a matrix. That's a no-no. Okay? How this is done is I want to move, and I'll put it in air quotes again, I want to move the identity matrix from the right side of this matrix notation to the left side. In other words, I want to perform row operations such that I end up with the identity matrix on the left-hand side of this expression. When that is done, when I perform row operations such that the identity matrix is on the left-hand side of the vertical bar, if you will, the right-hand side will be displaying my inverse matrix. So instead of the left-hand side being my coefficient matrix, I want to make it look like the identity matrix. Okay? Go ahead, pause the video, and that's what I want you to do. Perform row operations so that the left-hand side here looks like the identity matrix. Okay, go. You got it? Good. Let's go ahead. Okay. So this will take another 10 or 15 minutes probably, so long as I don't screw it up. But let's go ahead and get the inverse matrix. Okay. So what I'm going to do first, the first thing I'm going to do is let me multiply the top row, first row, by -1/2. That's the first thing I'm going to do. So let's go ahead and do that. And so I end up with something that says 1 3/2 and -1/2. Now, please bear in mind, again, our row operations say that you have to multiply everything by that constant. So on the other side of the bar now, I need to have -1/2, 0, and 0. Okay, now I haven't touched the second and third rows, so I'll leave it as is. And I struggle with the temptation to do more than one thing at a time. Don't do that. Okay. So I keep telling myself I'm better, so I should be able to go faster. And no, that's not the case. So there we go. So the next thing is I'm going to subtract. So what I'll do is multiply first row by 4 and subtract from second row. And in course, you can also, that's one of them. And the second one is add first row to third row. So I'm going to zero out the first column. So I'm not touching the first row, and excuse me, I'm going to scoot over to the right-hand side here, just because that felt a little cramped. So I'm going to go over to the right-hand side here. And so what we have, well, the first row we're not touching now. So we have 3/2 and -1/2. We have -1/2, 0, and 0. Now what am I going to do? Multiply the first row by 4 and subtract it from the second row. So I have 4 minus 1 times 4. I have -2 minus 3/2 times 4. And I have 1 minus -1/2 times 4. Put the line in there. Now, here's the next piece. I have 0 minus -1/2 times 4. Excuse me, not 44. I'm a little cramped here, so let me rewrite those. The second one, I have 1 minus 0 times 4. And then I have 0 minus 0 times 4. So those next two entries don't change at all. And then add the first row to the third row. So I have -1 plus 1. That gives me 0. Actually, I'll write it out. I have -1 plus 1. I have -1 plus 3/2. And I have 1 plus -1/2. I have 0 plus -1/2. I have 0 plus 0. And I have 1 plus 0. Okay, good so far? Of course, I'm going to clean this up. Okay, so I'm going to pause and jump to the next page, and I'll start off with that written up. Here we go. Okay, thanks for your attention, or your patience, I should say. Okay, so we've got it rewritten here, And of course, you should always double check to make sure that I haven't made any sign errors or anything like that. Okay, hopefully not. Okay. And so the next thing, what am I going to do? Well, I think the next thing I'm going to do is multiply the third row by 2. And then I'm going to swap second and third rows. So this is going to feel a lot like that Gaussian elimination process for a while. So I'm going to multiply the third row by 2, and then I'm going to swap it with the second row. So I don't touch the first row, so I go 3/2, -1/2. I've got a -1/2 here, 0 and 0. The second row, now don't forget, I'm going to do the swap. So let's see, I'd multiply the third row by 2 and move it to the second row. So I get 0, 1, 1, -1, 0, and 2. And then the third row is the old second row. So I'll just put -8, 3, 2, 1, 0. Now that I've got a 1 on the diagonal, like the identity matrix, now I need to zero out the entire column. And this is where we differ a little bit from the Gaussian elimination. Not only do I have to zero out stuff below the diagonal, but I want to zero out stuff above the diagonal as well. Okay? So bear that in mind. Keep that in mind. So what am I going to have to do? I have to multiply the second row by 3/2 and subtract from the first row. Right? I need to multiply by 3/2 to get to equal this value that I'm underlining here. And then I need to subtract it to make sure that this element ends up being 0. Okay. So let's go ahead and do that. And also, I'll have to multiply the second row by, let's see, 8. 8, and add to third row. And hopefully you also see why it's important to kind of note what you're doing. If you make a mistake somewhere, you at least have some idea of what you're trying to do. Okay? That's really important. Also, if I'm grading, I don't know, like your homework or an exam, you want to make sure that I know that you know what you're doing. Okay, so there's a twofold benefit to doing this. Let's go ahead. So multiply the second row by 3/2 and subtract from the first row. Well, 0 times 3/2 is 0, so I get 1. I have 1 times 3/2, so I get 3/2 minus 1 times 3/2. And then I have -1/2 minus 1 times 3/2. Now we got to keep going though. So don't forget we got the other side here. So we have -1/2 minus -1 times 3/2. We have 0 minus 0, so we'll put 0 in there. And then the last one, I have 0 minus 2 times 3/2. Oh, I'm going to run out of space here. That's okay. I'll just have to go to the next screen. That's fine. The second row doesn't change at all. We have 0, 1, 1. And a -1, 0, and 2. And then the last row. Okay. Well, 0 plus 0, so we get 0 again. Okay. And don't forget, I'm multiplying by 8 and then adding. So I get -8 plus 1 times 8. And so what do I get? I have 3 plus 1 times 8. Keep going. I have 2 plus negative 1 times 8. I have 1 plus 0. Okay, so that one's still just 1. And then I have 0 plus 2 times 8. So like I said, it still feels a little bit like that Gaussian elimination, but we have both sides of the equation that we have to worry about zeroing out top and bottom. Whew. Well, let me go ahead and rewrite this, and I'll write it up here in the top corner, and then we'll go to the next page. We'll just go to the next page right now. Pause. Ta-da! Okay, we're back. So I've just simply simplified all the addition stuff again, and we're almost there, right? We're 2/3 of the way there. We just simply need to get 1 in the 3-3 position and then 0 out the column. Well, we see what we need to do in order to get 1. We have to divide that third row by 11. So divide row 3 by 11. So let's go ahead and do that. Now, this last step is going to be a bugger, right? Ugly numbers, but such is life sometimes. You don't get to choose the numbers. It's what we do with the numbers, right? -1, 0, and 2. And we end up with a 0, 0, and a 1. A -6 over 11. A 1 over 11. And a 16 over 11. Ugh. Ugly, ugly, ugly. Don't like that 11 at all. Who came up with these numbers? Okay. Right? Now the last thing that we need to do is zero out that third column. In other words, we need to, it depends on how you want to do this, but let's say subtract row 3, third row, from second row. Right? That will take care of zeroing out the 2, 3 element. Okay, right here that I have underlined. In addition, what do we need to do? We need to zero out the 1, 3 element. We want to multiply third row by 2 and add to first row. And that will get rid of this 1, 3 element. Easiest path around is straight through. So let's go ahead. We have 0 times 2 and added to 1. So we have 1. We have 0 times 2 and added to 0. So that gives us 0. So those are a good start. Nice start there. We have 1 times 2 and added to -2. So we have -2 plus 1 times 2. Other side of the bar, and this is where, right, this is where the stuff gets, the left side looks simple, the right side gets really ugly. So the other side of the bar, what do we have? We have -2 plus -6 over 11 times 2. We have 0 plus 1 over 11 times 2. And we have -3 plus 16 over 11 times 2. So we'll have to get common denominators and all that kind of stuff. Okay, yeah. Okay, second one. subtract the third row from the second row. So 0 minus 0 is 0. 1 minus 0 is 1. And we have 1 minus 1. So we have to subtract the third row from the second. So we have negative 1 minus negative 6 over 11. We have 0 minus 1 over 11. And we have 2 minus 16 over 11. And fortunately for us, the third row, we don't have to touch at all. We have everything taken care of there. Good so far? And we're done. We're home free. Of course, we have to simplify. So let's go ahead and let's simplify this. So I'll go ahead and write it up on this white space that I haven't been using. So the left-hand side now, we should verify that we indeed have the identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. So we have now successfully obtained the identity matrix. On the right-hand side, well, let's go ahead and simplify this. Negative 22 over 11 minus another 12. So this is what? Negative 30. What am I thinking of here? 12 over 11. Oh, okay, pause. Timeout. Found an error. Sorry, guys. Let me highlight it here. Instead of negative 2, you probably already caught this. That should be a negative 1. Shameful, right? A 1/2 plus 3/2. Oh, excuse me, it's not even negative. A 1/2 plus 3/2 is not negative 2. Should be a positive 1. Excuse me, I had some errors there. So this is not a negative 2. This is a positive 1. So this is a positive 1. Okay, order has been restored. I apologize. I got a little confused there for a second. Okay, so now let's go ahead and simplify. And what do we have? We have 11 elevenths minus 12 elevenths. That gives me a minus 1 over 11. We have a 2 over 11. And then we have, let's see, 33 plus 32. I should say negative 33 plus 32. So that gives me a negative 1 over 11. Okay, so let's go to the second row. I have negative 11 plus 6. So that should give me a negative 5 elevenths. I have a negative 1 over 11. Let's see, I have 22 minus 16. So that should give me 6 over 11. Last one, of course, we don't have to touch at all. This should be negative 6 over 11, 1 over 11, and 16 over 11. So we have accomplished the task that we set forth. I said, hey, if we can make the identity matrix on the right-hand side, then this left-hand side is indeed my inverse. Let's take a step back. What did we do? Well, if I go back to my equation notation rather than this matrix form, what have we done? We now have the identity matrix being multiplied by our unknown inverse matrix, and that now equals this rigmarole right here. this rigmarole. Put that right there. But we know that when we take the identity matrix and multiply by any other matrix, it should return any other matrix, right? So that means that this rigmarole that I have here, this -1 over 11, this 2 over 11, this -1 over yada, 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 that is indeed the identity matrix, or excuse me, the inverse matrix. And you can see how it's not particularly nice looking, and it's more than just taking individual matrix elements and flipping them. And I'll box that in for us. Okay, let's go ahead and use that. I argued that once we have our identity matrix, we can then find the solution to our equations. Let me go ahead, get a new page, and I'll write this down. Okay, we're back. So I've gone ahead and I've reminded you that now that we have the inverse matrix, I can have my variable matrix on one side, the inverse matrix, and to remind you from last video what B was, that was -1, 0, and 2. Go ahead, take a minute, pause the video, go ahead and do the matrix multiplication to find out what the values are for the variable matrix. You got it? Good, 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 good. Let's go ahead and walk through it now. So now that you've tried it yourself, let's go ahead and get the final answer. Okay, so I have to multiply across the row and down the column. And so we have a 3 by 3 being multiplied by a 3 by 1. And so my resultant, as expected, should be a 3 by 1. It's always good to double check what your size of your final answer should be. So let's go ahead. I have -1 over 11 times -1 plus 2 over 11 times 0 plus -1 over 11 times 2. So there is the first entry in my final answer. Moving down a row, and we'll still multiply down the column, we have -5 over 11 times -1 plus -1 over 11 times 0 plus 6 over 11 times 2. And last but not least, -6 over 11 times -1 plus 1 over 11 times 0 plus 16 over 11 times 2. Okay. And, oh, drum roll. Here we go. We have 1 over 11 minus 2 over 11. So I should have a -1 over 11. Next one, unless I've botched something. I hope not. Next one, I have something like 5 over 11 plus 12 over 11. So I get 17 over 11. There we go. And third, I have 6, right? Negative and negative. So I have a 6 plus 32. So I get something like 38 over 11. And we see that this exactly matches the previous answers. Yeah, there we go. Okay. Sorry, just mental block there for a second. Oh, man, I apologize. Excuse me. I've introduced an extra negative sign here. Excuse me. This should not be... My notes were actually incorrect. Excuse me. This should be 1, 0, and 2. Okay. 1, 0, and negative 2. Excuse me. So I've accidentally introduced an extra negative sign. Not to fear. We just put an extra... That's like I pulled an extra negative sign out. So we'll just change the sign of these final answers. There we go. Order has been restored. And so we see that we actually have reproduced the final answers that we found from the previous lecture. So you have now two different ways of actually going through and solving a system of equations. Number one, actually, I guess you could say three ways, but graphically it's not very robust. Number one is that you apply the Gaussian elimination and then back substitution, back sub. That's one way to do it. The other way to do it is to simply find the inverse matrix and then perform the matrix multiplication of the inverse matrix times that matrix B. And either one of those will get you to the same answer. Okay, so let's say that's enough for this video. What I will do for the next video, okay, I'm not going to do any more kind of row manipulations or how to do the inverses. The next video will be a shorter one on how to do this using the calculator, or if you want something a little bit more meaty, how to do this using MATLAB. Okay, so it'll be a shorter video showing you how to actually do this on a calculator or with the computer. Okay. I can't emphasize this enough. You still need to know how to do this by hand. Okay, so I want to show you how to use the calculator to do this faster. You still need to know how the calculator is actually doing the calculations. In other words, you need to know how to do this by hand. Okay? Just because you have a calculator does not absolve you from knowing how to do this. Just wanted to be clear on that. Hey, thanks for your attention. I'll see you next time.